Hi, Ritvik.
Hi,
How are you?
good. How are you?
Good. So, have you had the chance to do some practice problems?
Yeah, I did all of 2019 and all of 2008. 2008 multiple choice and 2019 FRQ.
Oh, look at you. Okay. Do you want to start with the 2019?
Yeah, so for 2019, I tried to do it all in an hour and a half. Um, I I left one part of one question blank because I ran out of time. So,
What number at the end?
no, so I sort of skipped around this one. Like, it was part of number three.
Part of number three.
Yeah.
Let me put up the 2019.
When do you leave for Ohio?
Wednesday.
Wednesday. Oh boy.
I know. I'm a little bit nervous.
It's okay. Do good.
Um, did a practice exit interview with my advisor. That was kind of helpful. Yeah,
That's good. I'm sure they'll really like you.
I hope so, because I don't have anywhere else to go. Yeah, it's a little bit scary right now. We'll see. A little bit scary. Yeah, yesterday I was trying to pick out my clothes because um, you can either wear scrubs or you can wear like business casual because we'll be seeing or I will be shadowing residents who are seeing patients.
Mhm.
Um, but yeah, but I like they said the scrub colors can only be anything but gray and black.
Yeah.
But I only have gray, so because all dental students wear gray. No,
Yeah.
at our school, like my class wears gray. At their program, hygienists wear gray, dentists wear black. So
Yeah.
I'm not allowed to wear any of those two colors, and I
Yeah.
only wear gray or black. So my advisor was like, "Oh, you and I are the same size, so I just bought some royal blue scrubs. Do you want them? Do you want to like borrow them?" I was like, "No,
Um,
that's too much. I don't want to borrow her stuff. I
yeah.
feel bad." But yeah, she was super nice about it. She was like, "Yeah, just borrow it." Yeah. All right, so let's do the 2019 first.
Yep.
Okay. What did you get for A?
SP2.
A. What about for B?
I drew a dashed line between an oxygen and a hydrogen on nitrogen. Um, so like
Dash.
at the bottom, like the bottom left oxygen, I drew like a dashed line.
Oh, I see, I see, I see. Like the dash lines. And this one, I guess you can't. You can't really draw it like that. So, yeah. Um, yeah, you can actually draw it like this too.
Okay. The oxygen has to be pointing towards the hydrogen.
Yeah. So if they ask you to just draw one dash line, just only draw one.
Yeah, I only drew one.
Yeah, don't go overboard because I usually try to go overboard, but it's really not frowned upon, but I just wouldn't.
Yeah. No, I'm
Teacher
sure
now,
like
yeah. As a teacher, I'm just like, yeah, don't do it.
okay.
Yeah.
Okay. For the next one, I got 17.9.
Yes, molarity.
Yep. Let's see. Okay. And then I said the dissolution of urea is endothermic because its concentration increases as temperature increases. So that means that more aqueous urea is formed as a result of the temperature increase because more moles of urea dissolve per quantity of volume. Le Chatelier's principle states that increasing the temperature of an endothermic reaction shifts equilibrium towards products. Since more aqueous urea is formed as a result of the temperature
You could
increase.
have actually just stopped there.
Okay. Okay.
Yep, just stop there.
How many sentences should I aim to have for like the longer ones?
No more than 3.
No more than 3. Okay.
Yeah. Just remember that a lot of these people that are reading it are old grandpas and grandmas who don't really have anything else to do in their life, so that they're spending their summer here.
Okay.
You don't want to overdo it.
Okay. Okay. And then for E, I said mass of urea used, temperature change as a result of the dissolution of urea, and mass of water used.
Hmm. Good.
And then for F, I got 174.7 joules per mole Kelvin.
174.7 joules per mole Kelvin. Good.
And that's fine with sig figs, right?
Yeah. So, because the entropy on the table
Yeah.
has 4 sig figs. So 4 sig figs is fine.
Okay. Okay. And then for G, I said delta H of solution is positive for the dissolution because its dissolution results in the breaking of intermolecular forces between urea molecules. And the breaking of these IMFs allows urea molecules to move relatively freely in the solution rather than be locked in a solid structure.
So I would not have given you point for that.
Okay.
Because when they're asking you for delta G, okay, first of all, they're giving you delta S information. They're also telling you.
Oh, sorry. I'm doing G.
Oh, yeah, sorry. You're right. Then you're right. Yeah. Because breaking them, you're increasing delta S entropy. Yes. Sorry. I don't know why I was looking at H.
Wait, okay, so I did have a question about that one. So, would I have to like specifically mention or like say something about how this would increase disorder? Because all I said is that breaking IMFs,
They're
like,
increasing number of molecules, and that is entropy.
okay, okay. And then one thing I was also wondering about was like you do have like it does be do I have to mention that it does become slightly like more like the water molecules become more ordered because of like the formation of IMFs between them and like the urea or
No,
no? Okay.
no. Only answer what they have asked you.
Okay. And then for H, I said, as mentioned in part D, the dissolution of urea is endothermic, meaning its delta H is positive. For a process to be spontaneous, its delta G must be negative, and delta G equals delta H minus T delta S. And this reaction has a positive delta H and positive delta S. Since delta G is negative, um, and this reaction is spontaneous in this case, T delta S must be greater than delta H. And since T is constant at constant T, delta S drives the value of T delta S, and thus drives the value of delta G, and thus drives the reaction.
Thus drives the reaction which direction?
I said
Thermodynamically
drives the reaction.
favorable. Yeah, towards thermodynamically favorable direction.
Okay.
Or you can just say drives the direction thermodynamically.
Okay. Could I also say towards the products?
Well, if you are already saying it's being driven thermodynamically, it's assumed that it's going towards products.
Okay. Okay. Um, for 2A, I said I circled I2, and I said it's because I atoms have the most valence shells of all the halogens and are thus the largest.
I atom has what?
It has the most valence shells of all the halogens. So it's the largest.
Wait, hold on. So you don't have most valence shells. Valence shell is the most outer shell. Every atom has one valence shell.
Okay.
And all halogens have the same number of electrons on their valence shell.
Mhm.
So I think you wanted to say it has the largest valence shell radius, right? Or the largest
Yeah.
radius. You wouldn't even say valence shell radius. You would just say largest radius.
Yeah.
Yeah.
So yeah, then I go on to say like it is the largest halogen atom by radius and has the
Yeah.
most electrons. So
Has the most overall electrons, not just valence electrons, right?
yeah, I just said has the most electrons.
Okay, good. Good.
And then I said this means that there will be greater electron-electron repulsions between two iodine atoms than two of any other halogen atoms. So the two iodine nuclei will be farther apart from each other than in any other diatomic halogen. So I2 has the longest bond length.
Good.
Okay. So talking about electron-electron repulsions is fine for that one.
Yeah.
And do you think I'd still get points off for like the slip with the valence thing?
So they don't take points off.
Yeah.
They just don't give you points, if you will.
Okay. So would I still earn the point then, even though I like sort of messed up with the valence thing?
Yeah, you would.
Okay.
But they, yeah, I mean, this is just 1 point. So honestly, it wouldn't make a huge difference. But yeah.
Okay. For B, I wrote Cl2 gas plus 2 Br minus yields Br2 gas plus 2 Cl minus. And I said that E cell is 0.29 volts. And since it's positive, delta G is negative, and it's thermodynamically favorable.
Good. That's literally all you have to say.
Okay. One thing I did want to ask. So Is it fine if I wrote in the equation, like I tried to write the states of matter, but I wrote gas for bromine instead of liquid. So
You
would
wrote
that
gas for bromine instead of liquid. So
yeah, like for
minus or
BR2.
for BR2.
Yeah.
Um, I don't think it really mattered for you to write the states here
Okay.
because this is electrochemistry. And in electrochem, most of them are going to be ions, which is in aqueous form.
Mhm. Okay. And then for C, I said BR2 has a higher boiling point than BRCl because it has more electrons than BRCl. Then I said molecules of both both compounds experience London dispersion forces, which depend on a molecule's polarizability. And since BR2 has more electrons than BRCl, it experiences electron density shifts more frequently than BRCl. So it forms instantaneous dipoles longer and more frequently than BRCl, so it has stronger LDF.
Okay. Yeah.
Okay. And then for the next one, I got 1.22 atmospheres.
Yes.
Okay. And then for E, I got the equilibrium is BR2 times CL2 over BRCl squared, and their concentrations. Yeah. And then for K equilibrium, I got 0.25.
No.
No? Okay.
Um,
Yeah, that felt wrong.
this is what you have. You started with 0.22, 0, 0, right?
Oh, wait, I did it based on concentrations, not pressures.
Shouldn't you be doing it where you did it? So it'd be half, but you found pressure.
Yeah. I just thought for K equilibrium, you use concentration, not pressure.
K equilibrium. So for gases, K equilibrium
Yeah.
is atmospheres, is pressure. That's
Okay.
default. Unless they ask you specifically for concentration, then it's Kc.
Okay.
So do you want to retry?
Yeah. Okay, so would it be 0.13 then?
Correct.
For the next one, I got 219 kilojoules per mole.
Correct. So this one is where you didn't finish, right?
Yeah.
Okay.
For A, I said CO3 2 minus plus Ca2 plus yields CaCO3.
Like that?
Yep. And then for the diagram, I added in Ca2 plus ions too, since they said they added in excess.
Yeah. That should be enough, right?
Yeah.
That's fine. As long as there's one more extra.
Okay. For C, I got 0.0093 moles.
Mm-hmm. Of sodium carbonate?
Yeah.
Yes.
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 Okay. And then for D, I said no, because if the precipitate wasn't dried, there'd be extra non-precipitate mass present. So the calculated moles of precipitate would be higher than expected. And since this is used to find the moles of Na2CO3, the moles of Na2CO3 would also be higher than expected. So its calculated molarity would be too high, not too low.
Yes.
Okay. For E, I said the liquid would conduct electricity because it contains freely moving ions in their aqueous form. So that means electrons can move freely throughout the solution and that it can conduct electricity.
Mm-hmm.
Okay. And then for F1, I said pH meter.
Yeah.
Okay. For F2, I said the student could measure the pH of the solution, then subtract it from 14 to find the pOH, which could be used to find concentration of OH minus in the solution. Then I said concentration of OH minus equals concentration of HCO3, since they're both created by the hydrolysis of CO3 2 minus and are in a 1-to-1 ratio. Then you can plug in their values into the Kb expression to solve for the equilibrium concentration of CO3 2 minus. And by adding the concentration of OH minus or HC3O minus, you can find the initial CO3 2 minus.
So the way that they did it is they just drew out the ice table and then they just
Yeah.
use variables like X, Y, and Z. Yeah.
Okay.
You could have done that too.
Okay. And then, so I skipped G and went to H. G was the one that I didn't have time to do. So should I try it now?
Sure. But what did you do? What did you get for H? Let's go through that first.
Okay. For H, I said no because it has a pKb of 3.68, meaning it has an effective buffering capacity between a pOH of 2.68 and 4.68. And then I said a pH of 9.32 to 11.32. Since a pH of 6 isn't in this range, an effective buffer with CO3 2 minus and
Oh, wait,
8CO3.
hold on. You said pH of what? 4.6?
No, I said pH of 9.32 to 11.32.
Because they gave you PKB, right?
Yeah, so I first solved for pOH.
Okay.
Yeah,
Good. Then yeah. Because here they only give it to me as pH. So I guess
okay,
if I were to convert it, yeah.
okay. So it's fine if I then said pOH and then converted to pH.
Yes.
Okay. Um, okay. Okay. For G, I said less than because CO3 2 minus is a relatively weak base, so it ionizes less than 5%. So the equilibrium concentration of HCO3 minus will be less than 5% of the equilibrium concentration of CO3 2 minus.
Were you able to calculate the KB or no?
No. Wait, was I able to calculate what?
No, because the KB for, they gave us the KB, which is 2.1 times 10 to the negative 4.
Yeah.
So you could have just said it's less than because the KB indicates that it's a very, it's favoring the reactants.
Yeah. Oh, okay.
Yeah,
So I
because
should
it's super tiny.
okay. So I should have said favoring the reactants
Yeah.
instead. Okay. Okay. I'm sorry. So I don't have to do the calculation for G then, right?
You
Okay.
really didn't.
Okay. For 4A, I said raising the temperature increases the motion of CO2 molecules by increasing their average speed.
That's it.
That's
Yep.
it. That's all I said.
Don't write anymore.
Okay.
I'm gonna cut you off.
Okay. And then for B, I got 0.99 atmospheres.
Yeah.
Okay.
2 sig figs, right?
Two sigmas.
Two decimal places. Yep.
Yep. And then for C, I said PCO2 changes as temperature increases to 425 Kelvin because as T increases, the motion of molecules increases. So they collide with the container more frequently, which registers as an increase in pressure of CO2.
Yeah.
Yeah. Okay. For D, I said actual CO2 molecules have IMFs between them, so collide with the container less than expected. In parentheses, I said they stick to each other more than expected.
So you have to.
That's fine.
That's fine.
Okay. So wait, I just wanted to clarify something. So the IMFs in reality make molecules collide less with each other than actual.
Yeah, because they're stuck to each other.
Okay.
Collision only happens when they're away from each other and they're like bouncing off of each other. But if there's no bouncing, then you can't say that they're colliding, right?
Yeah. Okay. For the next one, I got one S2, two S2, two P6, three S2, three P6, four S2 for 1A or A1.
Yeah.
And then for 2, I said calcium.
Yep.
And then for B, I got 2.03 times 10 to the negative 7 meters.
Okay.
And that's 3 sig figs, right?
3 sig figs.
Okay. For 6, I said the graphs indicate the reaction is second order because the graph of 1 over concentration of NO2 is linear with a positive slope. According to the integrated rate law, this signifies a second order reaction.
Good, that's it.
Okay. And then for B, I said rate equals K NO2 squared.
Can NO2 squared. Good.
Okay. And then for C1, I said yes, because the rate law for the elementary reaction that is considered the slow step is rate equals K times NO2 squared. Since the rate law of a reaction is equal to the rate law of its elementary slow step, when the slow step doesn't contain intermediates, this rate law is consistent with the one from part B.
So all you had to say for that last sentence was rate law for the elementary step for the slow step is consistent to the overall rate law, period.
Okay. So I don't have to mention the part about like intermediates.
No.
Okay. Okay. And then for the second one, I like did out like the whole substitution thing with the rate, and like I showed my work like that, and then I said yes because the rate law of the slow step is equal to like the rate law I found in part B. So would that be fine for just
Consistent with it. Yep, that's good enough.
okay?
That's what they wanted. So that was that one, only one problem you were not able to do within time?
Yeah,
An hour and a half?
yeah,
Okay. I mean, you get an hour and 15 minutes, so I think you're going to be okay. But I
okay,
still want you to be a little bit faster and a bit more concise.
yeah. Yeah, I think I'm getting better with concise. So
Oh, yeah. I think you're getting much, much better for everything.
okay. So for 7A, I said manganese because its oxidation number decreases from +7 to +2. And that's enough, right?
That's enough.
Okay. And then for the volume used, I got 26.20 milliliters.
26.20 milliliters.
Yeah.
Good.
Sorry, my brother needed something. For C, I
My
said
brother needs everything all the time.
he doesn't live like in the same city as you, does he?
He still needs everything all the time.
Yeah, I think younger siblings are just like that.
But you know what I've realized? It's kind of weird because my younger brother obviously is like, okay, he's like 5 and almost 6 years younger than me.
Yeah.
Growing up, like, you know, because of the age difference, like he's always going to be my baby, right?
Yeah.
That never changes.
Yeah.
What's the difference between you and him?
4.5 years, and like I can't believe that he's like grown up so much. Like,
But he's always going to be your baby, right?
yeah, yeah,
Yeah. It's like you can see that they've grown up. Like my brother is in law school. Like he's definitely an adult,
yeah,
but he's still a baby because
yeah,
it's weird. But you know what? It's funny because like right now, because you're in high school, you don't really see it. But once you're in college or maybe after college and you start meeting people, and we're no longer in the same grade or within the school hierarchy, whatever,
Yeah.
You meet someone who's younger than you, but they're like above you in career, it's like a different feel. Like
Oh, yeah.
my upperclassmen, I have upperclassmen who are younger than my brother,
Oh, wow.
but they're still like my upperclassmen, and I still like don't see them as babies. Like I see them
Yeah.
as upperclassmen. Does that make sense?
Yeah, that makes a lot of sense.
It's so weird.
You know, like I feel like the age difference is like so much like bigger when you're younger.
Yeah, but then after a while, age really doesn't matter when you're
Doesn't
like
Yeah,
in a career. Yeah, yeah, it's fun
yeah.
now. Okay, what else?
For C, I got 6.16 times 10 to the negative fourth moles.
6.16 times 10 to the negative 4 mole. Yep.
Okay. Um, and then I said no for D. I said no because this concentration of MnO4 minus is less than a tenth of the one being used currently. So over 10 times the volume of MnO4 minus will have to be used to reach the equivalence point in another titration. Since this urate can only hold 50 milliliters, this is not reasonable.
Good. That's it.
Okay.
Good. I think you would have gotten a 5 for this. My only concern is um, sometimes you look at things, you try to approach things in a more complex way than they really are.
Yeah. Yeah.
That's my only concern, but honestly, that's not a bad concern.
Okay.
Okay, and you said you did 2018?
2008 for multiple choice.
Oh, 2008 for multiple choice.
Okay, so like the AP test is on Friday. So what should I do between now and then? Like, should I just do more FRQs or should I also have like a day to review general content? Like,
Um, I would just do FRQs
mhm,
just because, unless there's like specific content that you want to go over,
mhm.
I don't, yeah, which I really doubt that you need, but
Okay,
yeah. And then we still have to finish the 2013.
yeah,
Because we need to finish the 2013 because we did up to here last time, 27, right? So we'll
yep,
finish that. This over here. And then we just did 2019, 2008. Okay. Let me pull up the answers for 2008. Number 1A, 2E, 3C, 4C, 5E, 6 boy, 7A, bless you, 8E, 9E, 10C, 11A, 12C, 13A, 14C, 15B boy, 16E, 17A, 18C, 19C, 20E, 21B boy, 22B boy, 23C, 22C, 23B boy, 24B boy, 25A, 26B boy, 27D, no, 26 is D dog. I don't know why I said B boy. Sorry. I don't know how to read letters. 26 B boy, 27 D dog.
wait, sorry, 26 B boy.
You're like, Vicky, learn your alphabet. 26 D dog.
Okay,
That's the
okay.
D dog. I'm so sorry.
I don't know, it's fine. It's early in the morning.
C, 29 B boy, 30 B boy, 31 C, 32 C, 33 A, 34 D dog, 35 C, 36 A, 37 A, 38 D dog, 39E, 40A, 41E, 42E, 43C, 44B boy, 45D dog, 46A, 47B boy, 48B boy, 49E, 50E. Can I just quickly run to the restroom?
Yeah, sure, of course.
Right back. Okay. All right, which ones shall we do?
There's 25 questions more that I did.
Oh, sorry, I forgot the second page.
Okay.
51C, 52C, 53D dog, 54D dog, 55E, 56A, 57A, 58D dog, 59B boy, 60B boy, 61D dog, 62B boy, 63B boy, 64D dog, 65C, 66E, 67B boy, 68B boy, 69A, 70B boy, 71C, 72E, 73E, 74B boy, 75B boy.
Okay, 3 wrong.
Ooh, nice.
Yeah, I think I like the multiple choice a lot better than the FRQ.
Okay. Which one?
Okay, 18 was the first one I got wrong. Oh wait, I think I see why.
This is a 2-to-3 ratio.
Yeah, I think I was calculating O2 instead of KClO3. Okay. Yeah. Yeah, I think I see where I messed up.
Okay.
Okay, I got 31 wrong then.
31 wrong?
Yep. I think I just did bad math on that one.
Oh my god, are you serious? This
Yeah.
is okay, Ritvik. I'm not even going to talk to you about this. Redo.
Okay.
Redo.
Redo it.
Yeah, redo it.
Okay. Is it C?
Yes.
Okay. And that one is just sort of guess and check, right? Like, but educated.
Mm-hmm.
Okay.
Yeah, as long as it's like a 3-to-7 ratio by mass.
Yeah.
I still can't believe you got this one wrong. What the heck?
I know. Um, yeah, I think if I had checked over my answers, I might have caught it. But I didn't leave time to check at the end.
That's okay. You'll have enough time.
Yeah, I hope so.
You will. What's next?
One thing I was wondering, just in general, I need to memorize the solubility rules, right?
I
Like,
would. Um,
okay,
Technically, that is no longer part of the exam.
yeah.
Uh, yeah, technically, it's not part of the exam, but I would.
You don't need to like know them for like than any of like the more obscure ions like fluorine or like
I wouldn't. I wouldn't.
okay, 43 I was a bit confused on.
43.
Yeah, 43.
Pure liquid in an open vessel boils at the temperature at which. So it's an open vessel.
Yeah.
So we want boiling happens when?
When I was confused between C and D. I wasn't sure if it's like I knew that it was when vapor pressure equals like uh, atmospheric pressure, but I wasn't sure if like there's some sort of like underlying mechanism that like would be a better answer.
No, that
No.
is the definition.
Okay.
Yeah.
Okay. Um. So then 40 E is not correct, like at all, or is that like also
It's average kinetic energy. It's how fast the molecules vibrate.
yeah?
So that has nothing to do with this because it can change phases or not, or it can undergo phase change. It's still all like moving.
Okay.
Itself is not telling you if it's boiling or not.
Okay. 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 47, I was also a little bit confused on.
Because H2SO4 is a very strong acid,
Yeah.
and water it will react very vigorously, and we just don't want acid to splatter out. We want water to splatter out if anything were to splatter out.
Okay.
And anytime you have acid and base react with each other, it's an exothermic reaction, so the solution will start heating up.
Okay, then 49, I was also a bit confused on.
Okay, the one that is pretty insoluble would be phosphate. Because obviously ammonium, very soluble, potassium, alkali metal, so very soluble, nitrate, always soluble. So it's between acetate and phosphate. Usually acetate, you have to remember that it is vinegar.
Yeah.
Um, Phosphate is a very weak acid, and it has 3 protons that it has to deprotonate.
Yeah.
So having to deprotonate more than one proton is always going to be harder than for you to, deprotonate one.
Okay. So it's phosphate because phosphate is a has a weaker conjugate acid than acetate.
Yeah.
So one thing I was also a bit confused about this, I remember that nitrate, the dissolution of nitrate is always endothermic, but it's still always soluble, right?
Right.
Okay.
Another thing that you should remember about phosphate is that it's in our DNA.
Okay.
It's in our DNA, it's in ATP, it's in fossils, it's in rocks. So if you look at it, these are things that they shouldn't be dissolving.
Right. Oh, right.
Yeah.
Um, So for that one, is it okay if I also did something like process of elimination? Because on the solubility rule sheet that you gave me, it said that like A through D were all insoluble, and then phosphate or they were all soluble, and phosphate was sometimes insoluble.
Phosphate is not some yeah, just keep phosphate as sometimes insoluble.
Okay. Okay.
But it's on the more insoluble side.
Okay. Um, and then 54.
So this one, if I remember correctly, this one you would have to do the Henry's law.
Okay.
Yeah, it's like partial pressure. It's like Raoult's law actually.
Okay. Okay.
C2H6O2 is equal to the pure pressure of times mole fraction of it, so
Okay.
1/10. Yeah.
And if it was volatile, then I would just take the average, right? Or like sort of a weighted average.
Yeah.
Um, Next one was 60.
60?
Yeah, 60.
Okay, well, it looks like this is creating, what is it creating? It's creating complex ions
Yeah,
because nickel is a very large transition metal, so it's absorbing all of them. And NH3, remember, it's a Lewis base, so it likes to donate electrons.
yeah.
So when it's absorbing it, all of a sudden you don't see NH3s anymore.
Mhm.
So it's a complex ion. It's forming complex ions.
Okay. So that sort of explains why it dissolves then.
Yeah,
Um,
because imagine, and so it's like this. Ni was paired up with NH3s like this. This is going to create a precipitate. But when it
okay.
starts to accept more NH3s, this is a complex ion now.
Yeah.
As a complex ion, because it's an ion, it's dissolving.
Okay. Oh, okay. Um, so at first you have a precipitate, because like it like actually reacts with NH3 to form something, but eventually it like just absorbs them to form an ion.
Yeah.
Okay. Um, and then 65, I wanted to check my reasoning. So I put C, and I wanted to make sure the reason that you move the tube downward to equalize the water levels is so that the atmospheric pressure on the inside of the tube is the same as the atmospheric pressure on the outside.
Correct.
Okay. Um,
Your total pressure of the inside.
yeah, total pressure. And then to find
Yeah,
the pressure of the gas, you subtract pressure of water.
correct.
Okay. Okay. Then 73.
So if they have the same volume and
Yeah.
they're both at equilibrium and same temperature, shouldn't it be the same pressure? Because P equals nRT.
Right. I just wasn't sure if like vapor pressure was dependent on like more factors besides like
No,
okay.
vapor pressure at the end of the day just means it's the pressure of liquid becoming gas. So it's literally the same thing as just regular pressure.
Okay.
Yeah, don't get scared.
Okay. Okay. So it's not affected by surface area of liquid. So in that case, would D or E be the better answer?
E.
Okay. So it's not really affected by volume of a liquid.
No, it has to be everything. Volume and temperature.
Okay. It's just that temperature affects it more than volume.
Yeah.
Okay. That was everything.
That was everything.
Yeah.
And let's go back to this. Is it too small?
No, it's fine.
Okay.
Is 28 C?
28 is C. Good.
Also, did you get the Moderna or the Pfizer when you
I
were
got the
getting?
Moderna.
Okay, okay. Yeah, because I got my first shot of the Pfizer on Friday, and the side effects weren't as bad as you were talking about yours. So I was,
Yeah. My mom also got the Pfizer, and she didn't. My mom and brother, both of them actually got the Pfizer, and they weren't. Yeah, they were totally fine. Like all
okay,
they had was like a little bit of arm ache and fatigue. Fatigue that lasted for like 3 4 days, but they were
okay,
yeah. So my friend also got Pfizer, and he was also fine. Like the first time, the second time he felt a little bit like I guess kind of like body aches and stuff, but he said he was totally fine. He was able. He took a day off of work because he wanted to, not because he needed to.
okay,
I feel Pfizer had less side effects.
okay, okay. That's good to hear that.
Yeah, because my other friend, she got the Johnson,
Yeah,
and she was in so much pain, so much pain.
nice.
Yeah, but I mean, I feel like they're all fine, but it's just I'm an outlier. I'm an outlier, so don't even listen to me.
No, because I know my mom got Moderna, and she had like similar side effects for the second shot. Like she had a fever. and like she had to take Tylenol, and yeah.
Yeah, it was bad. Like for me, I had side effects for both, first and second, but I think that was just because I'm an outlier.
Okay.
Yeah, I was so sick. I was so sick. But it didn't hit me until the second day, too, for the
Yeah.
first shot. Yeah.
Yeah. I was like anticipating side effects for the first one. So
But you're fine?
yeah, I was fine. I think I almost like placeboed myself into getting a headache, but
No, I'm sure you got the headache.
okay.
Yeah, it was not placebo, no. Um, we actually had a patient the other day that came in, and it was the funniest thing ever because this is like a big guy, and he was like, "Oh my god, I'm so afraid of needles. I'm so afraid of anesthetics. So can you please give me the laughing gas?" So we gave him the laughing gas. But the funny thing is, the laughing gas, like the connections, the pipelines, were
Yeah.
not connected.
Oh
So literally, everyone in the room was getting the laughing gas except for the patient. The patient was getting oxygen. But it was
yeah,
so funny because the patient, so we didn't find out about this until after we were done with the procedure. We checked the patient out um,
yeah,
when the dental assistant came in to clean up and stuff.
yeah.
And my friends were telling me because they were the providers, and it was just so funny. The patient was like, "Oh, yeah, this is really good. I'm actually feeling it kick in." But it was funny because he was actually not getting any.
Wait, so then everyone else in the room was like laughing during the procedure?
So the thing is, laughing gas it's a higher density than regular like atmospheric air, so it sinks to the bottom of the room.
Oh,
So it's not like we were actually like breathing it in,
yeah.
and the patient was definitely not breathing it in. But he was like, "Oh yeah, I feel so good. I feel so much better." My friends were like, "That was some real placebo effect right there."
Yeah.
So Um, Ritvik, why don't we do this? I'm going to put up. Let me see. I'm going to let me see what else you've done. 'Cause I don't have that many MCQs. I put up a whole bunch of FRQs, right?
Yeah. Um, most of them I've done, but I think I'm gonna do them again like this.
Okay. Have we done the 2016 multiple choice?
No, I don't think so.
Okay, I'm going to put the 2016 multiple choice here. Try doing it within an hour and a half. See if that um, works. See if you're able to do it. I don't have any other ones. Yeah, try doing that.
Okay.
And then we can finish the 2013 together next class.
Okay.
And
I'll also hopefully have done a couple of FRQs by then. So
yeah, I mean, we have the 2019, 18, 17, 16. I know you've done pretty much all of them, but see if there's one that you haven't done that you can actually just do faster.
okay.
We can go from there.
Okay, sounds good.
Sounds good?
Yep.
Okie dokie, Ritvik. Have a great rest of your week.
Bye. Have fun in Ohio.
Wow, don't I see you while I'm there? I think I do.
Yeah.
I see you Wednesday night.
Yep.
I'll text you as soon as I get in and see if I'm able to, yeah, do the tour.
Yeah. It's at 6:30, right? Or 6:30 Central.
6:30 Central. Um,
Okay.
but I may change it. I don't know exactly.
Okay.
But yeah, I'll let you know.
Okay. Let me. All right.
All right, sounds good. Have a good rest of your week.
Bye. You
Bye
too.
bye.